Hello, I'm going to tell you about FRA probe calibration. Our standard Cleverscope probes in the 1x switch position have a bandwidth of about 6 MHz. This can be improved to 10 MHz by using probe calibration. In addition, the probe has an input capacitance of about 56 picofarads. That capacitance loads the system under test and also loads the SIGGEN, which has got a 50 ohm output impedance. Using probe calibration, we can correct for these deficiencies in the standard probes. First off, we set the probes to the 1x switch position. We connect the two probe tips to the output of the SIGGEN and the two probe grounds together to the output of the SIGGEN ground. Now we're all set. The next mission is to start up the Cleverscope application and get the FRA set up. This is a short tutorial on how to set up the FRA probe compensation. First off, let's set the frequency range. I've used 1 kHz and 10 MHz. 10 MHz is about the upper limit for the one-time probe setting. I've set a signal generator amplitude of 2 volts peak to peak. I've set the scope display to capture plus or minus 1.5 volts. In that way we will be able to avoid any peak limitations. Right, we set the analysis type to gain phase and probe correction off, just to see what we would get without any correction. I'll sweep. I'm using 20 steps per decade and 1 kHz maximum bandwidth. You can see the frequency being swept in the scope graph. As you can see, we've got a gain variation of about plus or minus 0.1 dB. That's not too bad. Phase is varying between minus 0.3 and plus 0.6 degrees. Also quite reasonable. But if you want to get best accuracy out of your component measurements or the flattest gain phase response, you can use the calibrate probes analysis type. We start again by going start sweep. The FRA system now measures the gain and phase errors at each frequency and stores them in a file which gets saved with any setups you do or in any saved .apc files. Now we'll change it to gain phase with the correction on this time and run it again. Let's go. As you can see, the gain response is now flat. Quite a lot better than plus or minus 0.01 dB. The phase response is also quite flat, with a much better response than the uncorrected probes. By using the probe correction system, you can attain maximum accuracy in all the measurements you do using the FRA. We commend it to you.